So we're here to talk about persistence and performance in the real world of OpenStack. The agenda today is a little bit about Datera, company I work for. We're going to talk through some of the challenges with persistence and performance in a cloud environment, and then walk through the day in the life of the life cycle, if you will, of an application from development to retirement, with some demo videos along the way. So first, I want to give a big shout out to OpenStack. Happy birthday, which is why we're here. I just got started, John. I hope that's okay.
Yeah. I was going to. Sorry, I'm just having an HDMI cable upstairs. Otherwise, I would have run down to introduce you. Let me grab people, let them know that you're starting.
Okay, great. Then I'll leave it on the birthday slide for a second. A big thanks to John and Lisa Marie and the whole team who pulled this event off. This is the third birthday party that we've sponsored at Datera, so we're excited by that. Those who have been following OpenStack for a while have seen it mature quite rapidly in the last couple of years, and the market better understand what it is and who it's for. It's going to be an exciting year and an exciting time as containers come into play as well. So, who is Datera? I put this slide together because I think managing infrastructure is pretty simple for most people. There's a lot of logos. Most of these are actually new age applications. But this is a lot of what we hear from our customers is the problem they're facing. Is if you build a successful cloud, they will come. And when they show up, they bring with them their applications. And the diversity of applications and those requirements of those applications can put a lot of pressure on your infrastructure. And that is a major challenge when it comes to storage. It's not only the application side, it's also the orchestration and hardware. All of these things are basically a giant IT blender that as IT professionals we have to manage and deal with. So Datera is a 100% software-defined, software-based data services platform. So the idea is that we are software that you run on an x86 server. Server's got media, memory, compute, and networking, and then we federate those systems together to provide a very agile platform for managing the different applications and needs within your infrastructure. So some of our pillars are automated operations to take that operational overhead off the system, deliver the maximum performance for the hardware platform. It's actually a very hard thing to do. We heard from our previous speaker, the folks at SoftIron, the work they've done to optimize the hardware for delivering Ceph. Datera has done a lot of work to optimize the delivery of I/O on Intel-based platforms. We talk about at scale. If you're going to build a storage infrastructure, you want to make sure it goes as big as you want it to go. It's often a question we get around the scale, and we'll talk a little about that later. Talk about enhanced data services, capabilities like snapshots, cloning, compression, deduplication, the sorts of things that people in the storage world care greatly about. It's hard to find those in a software package that is also performant, and we can deliver that. Along with that freedom, the capability to run it on different hardware, different media types, to be able to make mistakes. I'm sure everyone in this room has never made a mistake in their life, and in the IT world, never picked the wrong thing to run an application from a storage perspective. With the Datera platform, we can free you of that challenge. So a lot of our customers look like this when we show up. They've got a variety of different vendors. If you've worked with storage, you'll recognize the big names. A ton of different applications running in different infrastructures. Not everyone is fortunate enough to be able to run a pure OpenStack infrastructure. So they buy different products to solve different needs. You end up with rigid silos, trapped capacity, trapped performance, different protocols. It gets very painful. And there's also high operational overhead. You're dealing with different storage vendors, different parts, nothing's interchangeable. If you need to buy a new drive, you have to get it with their firmware. These things are all very operationally challenging. And when customers use Datera, they end up with something like this, a single software platform that can manage all the different workloads and manage the infrastructure and do it in a way that's policy driven. So if it needs to go faster, you buy faster media, you plug it in, change the policy, and this platform itself makes that data migration. I'm pretty sure everyone who does infrastructure is familiar with VMware. As a storage geek, one of the main things that VMware brings us is that storage vMotion. Has anyone here ever storage vMotion to VM? Like, actually moved it? If you had to do it the old way of like, I have a database, I need to copy it, oh my God, that sucks. If you can just vMotion it, it's magical. But that's only a VMware feature. So if you're moving away from VMware for all the good reasons to do so, you're going to lose that. Our platform does this innately. It's built in. It's part of that automation capability that you can direct us to do it, or we can determine when it happens, and we can move stuff automatically, because our fundamental architecture is about virtualizing that data placement and being able to move it around. We also support multiple protocols. The previous speakers were talking about Ceph. Obviously, Ceph is a major storage platform for OpenStack deployments. Ceph is a good platform for a lot of people, but it's not for everyone. And so we find a lot of our customers interested in looking at other alternatives that might be a little bit more supported and a little bit fewer knobs. So I want to talk about what we've seen as challenges for persistence and performance. You know, when we think about this, there's a bit of the Goldilocks problem, right? If you think about the Goldilocks story, it's all about getting it just right. But when you think about it, capacity can be cheap. If you're buying spinning media, I bought a couple of 4 terabyte hard drives off of Amazon. They're certified refurbished because they're from my home. $79 a pop for 4 terabyte drives. It's ridiculous. Capacity can be cheap, but performance is expensive. If you're looking at buying the latest Intel Optane persistent memory device, that's about $2 a gig, give or take. The price hasn't come down on those yet. So if you're trying to get to that just right, you have to balance that capability. You know, we think about hybrid nodes was a very common approach and still is in a lot of cases, but that's not the best fit for every use case. So what you really need is a system that allows you to be very agile in terms of what the system looks like, but it's not only just from a deployment perspective, but it's also relative to the applications. If you recall the slide I had up there, there's a very popular application called Kafka. We'll have a little demo of that later, showing a visualizer. Kafka is very write intensive. Only when there's a failure do you read off the media. Otherwise, it's typically run out of RAM. But other applications like certain databases or Logstash, they tend to be very read intensive. So now how do you balance those when you're trying to make a simple system? Very, very difficult. So it gets us into that competing requirements. Do you want to have agility, or do you want simplification? Do you want to have scale, or do you want to mitigate that risk? It'd be great if we could put everything in one giant control plane and manage 1 million servers from one spot, except for computer science doesn't allow that. The physical distance between the machines is going to start interfering with that control plane. Shout out to my friends at Platform 9 who know a lot about this problem and do a lot of that work. What you want to do is you want to try to go back to that Goldilocks and you want to get it just right. The right amount of scale before you draw that line and build another one and then federate them with services above that. Going back to that cookie cutter versus diversified workload. It's easy to sit in a room, draw a rack, put some lines in it and say, this is what we're going to deploy. We're going to use 2 Intel processors, this class, this much memory, and we're going to put 1,000 of these racks out. That absolutely will work until you talk to enough users, and then it will not work. The evidence of this is very simple. Look at Amazon. If anyone's used AWS, if I remember it's like 5-6 years ago, it was beautiful. I had 4 choices for compute. Now you look on the same page, it's like I-class, Rs, Ms, it's ridiculous the number they have because they need to support those applications. They wouldn't bother setting up all these different types if they didn't know they needed to. That's the challenge. So if you're building these clouds and you want to build for performance and persistence, you got to be thinking about how can I get the right amount of agility so it's just right in terms of those compute footprints. There is a use case for those cloud servers that Supermicro makes. Single socket, small node, dedicated, no noise. Our friends at Packet are very successfully deploying those. But it's very difficult to do for a lot of companies. So when we start talking about performance in storage, performance is hard. One of the things about performance that makes it so hard is performance is very relative. What I think is fast might not be what you think is fast. It's a very relative conversation. And then you have the application. It might be fast for Kafka, but it might be slow for Oracle. So there's a very fine line you have to walk there. There is no magic. I used to work at a hardware startup, and one of the hardware engineers told me, there's no magic. So there's something that has to do this. People have designed it. It's not magic. It's engineering. And what that basically means is that the storage media is going to drive your performance. It's very difficult to be faster than the media for any kind of sustained time because you're just reading from a different type of media called RAM. So the media choice is very, very important to meet that performance, but performance is always going to be relative to what you're trying to achieve. So going back to a cookie cutter or single approach is very difficult to make work at scale with a lot of different apps. And the media that you will find varies wildly, both cost and quality. So the Intel guys make some great drives. Samsung makes some great drives. There's definitely other vendors that make very affordable drives, but you'll find those edge conditions will bite you if you push them too hard. So that's another challenge when you're building for performance is it might seem great on paper. Oh my God, this drive is half the cost of the other drive. But there's a reason for that. And then another major issue is locality. You can have the world's fastest storage infrastructure, but if it's 25 milliseconds away from your compute, that does not matter. You have to be very cognizant of where is the locality of the data relative to the workload that's accessing it. If we could solve that whole speed of light problem, then this would all be very easy. We could have a centralized storage system and just use that. And then the last thing is tomorrow is a day away. It's going to be tomorrow, and there'll be another one after that. And a lot of times when people are trying to build for persistence and performance, they're very focused on day one. What does it take to build it? What do I imagine the problems are going to be? And you set that down, and then you get there and realize that you're not in a good spot. And so you want to be thinking about those operational challenges. What does it take to fix it if it breaks? That might not be the guiding principle for your decisions, but it's something to think about as you're architecting these solutions. How do I take advantage of new media? How many people have heard of NVMe? A few people? We're at Intel. We're at Silicon Valley. It's pretty geeky, right? NVMe is an interface, typically to NAND storage. You're never going to find an NVMe spinning drive because there's no point. The purpose of NVMe is it accelerates the protocol between the hardware and the media, the NAND flash. So being able to take advantage of those accelerations is very important if your system can do that. If you don't have an infrastructure that can take advantage of the new media, as the price changes on these new technologies, you won't be able to roll them into your infrastructure. And that's a real concern today because we are seeing the SATA, SAS, NVMe interfaces start to converge with U.2 and other standards. You know, going back to understanding that cost of getting it wrong. You know, I don't know if people here invest, like we all want to invest our money. It's always about the opportunity cost. What could I do with this money as opposed to, you know, buy that Ferrari because I want to drive a nice car. But you want to think about that from operations too. If I do this, what does it mean? What are the types of people that I'm going to need to manage the infrastructure? Those sorts of questions. And then lastly, and we'll get into the video here shortly, what does the life cycle look like? You know, the applications have a life cycle to them. Whether they're stood up and sunsetted or retired because the technology changes or because the requirements change, but they tend to have that life cycle. Some applications stay forever. One of my favorite pictures is a desktop tower in a rack with a pencil taped to the CD drive, because when the computer reboots, the drive extends and the pencil hits the front of the rack so the drive retracts. Because if it stayed out, the server would not reboot properly, and whatever that application is wouldn't run and the whole company would crash. That kind of stuff does happen if your applications live too long. So what I have is a couple of videos here to walk through the functionality. So what we're going to do first is leveraging the OpenStack infrastructure. So this is all OpenStack CLI commands and some UI commands. We're going to take a application from development to production, if the video plays for me. So this is a visualizer for Kafka. Very, very simple demonstration. What we're going to do is we're going to take the application that's currently running under Ceph, and we're going to use the Cinder retype functionality to move that over to be a Datera volume. In this version of OpenStack, and probably for a few more, that is a little bit of an offline operation. Luckily, this is development, so it's not as important. But the idea is that we can leverage the OpenStack infrastructure to sort of do that storage vMotion. But I mentioned before, OpenStack doesn't do that online. It's got to be an offline operation if you're moving between different backends. So in this case, Ceph and Datera. See, I think I refresh here. I don't know if you can read that. My apologies. This is not for a smaller screen. But what we basically did is we retyped it from Ceph to be a Datera type. So next we're going to talk about managing the production infrastructure. So here we're going to grow those volumes, again using the Ceph commands, excuse me, the OpenStack commands. Unfortunately, this version of OpenStack was Newton. It doesn't support an online resize. It's getting better. The Nova team and the Cinder team need to become better friends to fully support that. But the idea is we're going to execute a command. So we'll take one of our, if you don't know Kafka, it's a distributed application. There's 3 of them running. So we'll take one of them down. We'll do an extend from, I think, 60 gigs to 600 gigs. And that all becomes a back-end operation on the storage side. Then bring it back online and roll through the rest of them. So here we're doing that extend. Because it's a back-end operation, it's very fast for the system to grow that volume and to make it available. So just a little bit of pause. You notice the message sizes have got a bit bigger here because we have faster storage on the back end. So we're rolling through and extending that. And all of these scripts are in GitHub if you want to see the actual OpenStack CLI or API calls. So now that's done, what I was going to do is because they're now Datera volumes, we can leverage our Datera policies, and we're going to change real time from what we defined as bronze, so sort of a lesser expensive metal, to gold, which you'll find is a more expensive metal. So this is just using the built-in Cinder retype commands. Most people don't even know you can do this because most backends don't support it very well. Let me see if I can pause. But the idea is that within the OpenStack Cinder project, there's a concept of a type, and Cinder provides the ability to move between 2 types. You can say, I want it from this type to this type. If your storage backend supports it, it can do what they call a fast path, where it just changes properties on the storage side. If it doesn't support that, then it has to take the slow path, which requires downtime in the application. So one of the things about the Datera system is it's very policy-driven. So making changes to the application or the volume, such as the capacity, the performance, even the media placement, which we'll do next, is a fast path operation. So here I think we're going to do the media changeover. So I'm logging into the Datera side. This is the Datera user interface. I'm going to actually extend this cluster of 3 nodes to get started with 2 additional flash nodes and walk through that process very quickly here. I edited the video a little bit so you don't have to watch the little spinny wheel for 2 minutes. That one. So what's going to happen is the system is going to automatically bring those nodes online, format the media, do all of that sort of automation side on the storage front. And then now that becomes available, so we can go to the OpenStack and again execute that retype capability to then move that application non-disruptively at this point from a hybrid where you have flash and disk to an all-flash presentation. Within our architecture, those other nodes could be Intel Optane, it could be NVMe. The way we've designed the system, that's actually not that important to us. It's the ability to move that data back and forth is the important part. So here I've just changed it from a gold policy to the platinum policy. And that platinum policy I think has 5,000 IOPS and an all-flash presentation. So we're seeing these nodes come online and the system's going to automatically relocate that data. You don't have to do that from an operational perspective. So the last action we're going to do is again a retype. But this time, instead of going from a slower class to a faster class, we'll go from the fast class to an archive class. So again, talking about the system, it can support a wide variety of nodes. Maybe you want to optimize for $ per gig, and you want to get the lowest price. All that means is you have a lot of gigs over the server, because the processor's relatively fixed, memory's fixed. If you have a lot of hard drives, a lot of gigs, it just makes the economics work out well. So I'm just going to use the retype again, execute that command. It's on the back end going to change that placement, and Datera is going to automatically move that data. We called it pyrite, by the way, is the metal type, which isn't actually metal, but we thought it was funny. Pyrite, and save it. That's it. So now we've just archived off that application. One of the nice things about OpenStack is you have those controls. You can expose different types to different users. It's got a lot of capabilities there. It's very well integrated with the Datera. Okay. So just to wrap up, this is the end of the presentation. I hope I got pretty close to time there. The idea is that we built a data services platform, but not that supports OpenStack, but also supports other systems. So going back to that first slide with all the applications, Datera is a platform that can manage to provide storage to any of the orchestrators for any of the applications. Okay. Any questions or feedback? Oh, yeah.
Yeah, can you go over and explain the differences between Portworx, Pure Storage, and Datera?
Yeah, so the question was explain the differences between some of the competitors, new and older, in the market, specifically Portworx and Pure Storage versus what we do. I'll start with Pure. Pure's been around for a very long time. It's an excellent product. They came into the market bringing Flash, and they really have done a great job bringing Flash to the enterprise. The challenge that I see with that is that the hard drive, as much as we want to get rid of it, still has applicability in the data center. So it would be nice to go all Flash, but not everyone can afford that. So typically, what I've seen is companies would buy a Pure Storage device for a high-performance database application or a very high-performance application, and then they would buy something else for everything else. And we don't think that's the right solution. We've built our software so that we can drive similar performance from commodity hardware using a Supermicro, HP, Dell server, and we can get very close to the types of performance that the Pure can deliver. So we can not only support those database applications, we can also do spinning drives and archive for the rest of the workloads in the data center. And then Portworx, you brought up, is a very interesting company. They're a startup focused on containers. So if you have a container use case, specifically for containers, they provide some orchestration services in the container space. They do manage what I would call I/O strategy, like placement on disks, but their focus is more around that integration between how the container gets data and providing services from a container perspective. Datera supports container environments. We present multiple protocols, including iSCSI, so we can still attach and operate in containers, and there's a bit of crossover between what the two companies do. It's just we're focused on running across a large number of orchestrators as opposed to specifically in the container space. Is that helpful?
Yeah.
Great. Anything else? Thank you for the question. Okay. Very cool.
Is this a solution meant for HSM?
Typically, HSM is hierarchical storage management. What I've seen there is they use a stubbing technique where you can have a high-performance access, and then as the data ages out, sort of move that off to something a bit slower. The more modern name for that, I think, is data copy management. So yeah, that's something that our platform can manage. Not in the same way as an HSM, so we wouldn't like destage to tape, which is pretty common. But we can target where the data is placed in terms of those physical nodes, the media type, and produce a similar response, but really targeted toward primary storage, right? So you typically wouldn't see HSM in a high-performance database, right, in that kind of model. You'd see it more in file servers and more for the archive side. At least I've seen it historically. So we can do similar techniques to lower cost, but for primary storage. Any other questions? Yeah.
You mentioned you'd get to size later. What's the sizing that you guys have scaled up to and stuff like that?
Yeah, sorry, I did mention that. I think that might be the lightning talk. Sorry, it's not a lot of sleep. But from a scale perspective, it's always an interesting question. It's about managing that blast radius. If it fails, you always have to think about if it fails, and it's actually something people are not very good at. There's all sorts of research on this particular topic about how people think about success versus failure. Like we do a lot of work to manage for a disk or a server failure, but while it happens, it's not that common. If you have a lot of disks, it's going to happen. If you have a lot of servers, it's going to happen. But from an individual server perspective, it's not that big of a deal. But as we talk about building for scale, There's other boundaries that you think about, whether it's going to be at a rack level. Think of the physical data center, the physical infrastructure. You want to put it a rack? Do you want to do a row, collection of racks? You know, how big is a row in your data center? If you own it, you can make a row 200 feet if you wanted to. Most people don't. Again, that subdivision. So from a scale perspective, today we support up to 64 nodes. If you're using a mixture of flash, archive, you look at compression and deduplication, you can get 5-6 petabytes in that kind of footprint pretty easily. But then the question becomes, how much risk are you for what type of failure? We do a lot of work within our software to mitigate risk, but there is no magic. We are just people. And so what we found, most of our customers are interested in getting into the, say, 16 to sort of 40 scale before they subdivide that infrastructure and then either use zones with an OpenStack, or just depending on the technology, there's different ways of subdividing infrastructure. So a lot depends on the goals that are trying to be achieved, but I'd say sort of 16 to 40 is about right for most folks. Again, 40 nodes with a deduping hybrid that would have roughly maybe 400 terabytes of usable capacity, and you have the network to move all of that. 40 times 400 is a really big number. It's a lot of storage. Any other questions?
Just curious about the solution comparison with the Nutanix.
Sure. So the question is around comparison to the Nutanix solution. It's interesting. Nutanix is a storage company, certainly from a DNA perspective. The one thing that they've done different, a few others have done this, but they're very successful at, is hiding that fact and putting it underneath VMware and wrapping their own hypervisor on top. I mean, they're really the kings of hyper-converged. We are not hyper-converged. We make arguments to say that separating storage and compute still makes sense. And I'm happy to go through that at a different time. But the Nutanix solution is really focused on a single delivered platform that solves all of your IT problems and is very simple to operate. The Datera solution is designed for folks who want to optimize their infrastructure because they tend to be buying at scale. And they are looking to save money and to get a bit more agility in terms of what they're able to do from a storage perspective to deliver their business. That's the biggest difference, I would say, is Nutanix is kind of the easy button, and God bless them for that, $10 billion valuation, it's fantastic. We're focused more on larger scale deployments and folks who are more interested in optimizing each part of the stack individually.